Thanks, everyone. My name is Jan Straznicky from Ciena, Senior Director of Product Line Management, as mentioned. Happy to be back again. I'm going to kick off sort of the last section here, which is more about IP optical convergence, really kind of highlighting a couple of key things. We are seeing a lot of evolution and adoption of coherent routing, and that's really the marriage of coherent optics within routing platforms. So I'm going to spend some time talking about how we're sort of expanding the scope of what coherent routing means to service providers and what that allows them to do from a service perspective. But I'm also going to talk about a couple of key enabling technologies that Ciena invests in year over year to kind of improve the solution that we can provide. And if we get going here, one of the things you'll notice is that if you go back multiple years in Ciena's presentations at this event, you'll see sort of a building story of what coherent routing is. And last year we spent a lot of time talking about three key things, right? Faster, better, and more. And really what we meant there was really a focus around the growing of the capacity from 100 gig to 400 gig to 800 gig, how that evolves the architecture that service providers can build out, and also how do you manage that more effectively from a multi-layer perspective. And so what we're going to do here is kind of key on some of those things and the evolution of what's changed since last year. Now, like I said, the discussion's been previously around how you go from a 100 gig base kind of service from an aggregation perspective to 400 gig, whether it's for aggregation or DCI. And sort of the evolution towards 400 gig to 800 gig is kind of on everybody's mind, and I expect there'll be a lot of discussion about that after me, and there was already discussion about that before me. But the path in the DCI and the aggregation space towards 800 gig is clear. We're obviously key in investing in that technology, both from a optics perspective, given we're Ciena, but also on the platform perspective, from a routing and switching perspective, and also on the optical platforms. So that's key from an investment perspective for us. But adjacent to those two parts of the network, or to that part of the network, both in the access and in the core, we see the sort of bleeding out of the concept of coherent routing into both of those parts of the network and what that means. And really, when you start looking at on the access side, it's really about pushing the coherent technology closer and closer to the edge of the network. And in the core, it's about better cost per bit as you go long haul for packet services based on IP. And when we sort of look at how the evolution has gone from a coherent access perspective, this has been a multi-generational evolution. We first started out with coherent routing being a ruggedized router with a CFP2 DCO in it. That obviously limited the business case associated with that, because the density cost per bit wasn't very good. And also it led to a lot of interop challenges. So we moved to the next generation. This brought the QSFP and QSFP 28 introduction, allowed us to get more of the cost effectiveness on the routing platform side, but it still prevented more distributed deployment because you didn't have a ruggedized optic. Ciena continues to invest, continues to innovate in this area, and we just announced and released our first industry-leading extended temperature range 400 gig ZR plug that's really going to sort of bring the whole package together and really enable the deployment of this more remote from local or service provider points of presence. So why does that matter, right? What do you care? Why would you want to be pushing coherent routing from the POPs outside into the access and to the customer edge? Well, if you're a service provider and you're sort of trying to grow your service footprint, you're trying to get more customers, whether they be rural expansion, right, to upgrading internet service to rural neighborhoods and towns. You're going into new residential areas that are being built, new business parks. You're obviously going to want to establish a connectivity beachhead in there, right? And to do that, you need some form of networking to get you there. What you don't want to do, or what you want to do, is invest in the networking technology that makes it happen and allows you to deliver the services. Where you really want to optimize your investment is deciding, well, do I actually need to build a point of presence closer and closer to that area to service those customers? And I think this is one of the key things that coherent routing in the access really enables, is really an efficient way to capture new markets with using the existing footprint that you have. And so where we've seen a lot of work with some of our customers is the idea of pushing that coherent, service termination point closer and closer to the edge, allows you to accelerate the expansion while still maintaining that lower cost on the infrastructure side, pushes you deeper and deeper into the access. And what it allows you to do is deploy either a weatherized or cabinet-based routing platform, significantly extend the unamplified serving area, and also could be even more if you do introduce amplifiers in that area, but overall improving service performance. But the key thing here is that it doesn't require any new physical build from a point of presence perspective. Some of our lead customers are really excited about this, and there's already public announcements about how they're doing this and why they're doing this. But some of the customers we're working with have done obviously modeling about what benefits this brings them. And from an overall service coverage perspective, just the fact of being able to put a router, weatherized router, out deep into the access to serve growing areas expands their service footprint by a factor of 9. So 9x increase in service coverage without actually having to deploy any new physical points of presence. So really advantageous in that sense. Now, if we shift from the access, well, actually, one thing that I will point out here, and it was sort of brought up earlier. If I had been speaking, 20 minutes ago, a half hour ago in the SRv6 section, what I'd also be highlighting here is that these new routers that you're deploying allow you not only to push the coherent edge, but this is now your service termination point, right? So you can pick up more business based on SRv6 EVPN services right at the edge of the network. So it's sort of been talked about in previous presentations, but this is actually enabling that as well. If we move from the access, bypass the metro, but focus more on the long haul, last year we did talk about the economics of all this, and we sort of all concluded that 800 gig is basically becoming the new economic baseline across most scenarios. And I think the one scenario where we saw that it was still much better cost per bit performance was really around long-haul IP transit and transport, where we could use our embedded modem technology that's rated at 1.6 tera at the maximum to be able to reach extended distances, 2,700 kilometers and above, on a single wavelength. And we actually have customers now who have basically made that a reality in the network, where they've, between two very disparate POP locations, offer wholesale services, 10 gig, 100 gig, 400 gig, modernizing their whole service offering, better economics, all using this technology, but they're still having the flexibility to use the optical connectivity technology they need for the best economics of the service they're delivering. But when you look at the scale of capacity, we go all the way from 100 gig to 1.6. We're able to deliver a full suite of layer 2 and layer 3 VPN services based on modern transport and an evolution from TP to SR. But they can now do this over extended distances. And this is what allows them to really drive that lower cost per bit. So another example of how we're sort of moving the yardsticks ahead in terms of what coherent routing is to the service provider community. Switching gears a bit to a more technology discussion. Again, building on the theme from multiple years. Last year, we spent a lot of time talking about multi-layer visualization, planning, provisioning. This year, we're going to focus on a couple more other key items which are kind of completing the puzzle. One is around infrastructure utilization, and the other is about instrumentation. A colleague of mine, Juan Luis, this morning talked about AI and how the fidelity and the value of the data, having it correct, is critical, right? And so from Ciena's perspective, coherent routing hasn't been about just putting a plug in a router. It's about being able to do that while still being able to maintain all of the service richness, the data, all of that we get from the optical side, but embed that in the router. And usually when you look at the difference between an optical engineer and an IP engineer when it comes to this converged solution, what the IP engineer sees as two ports which build their layer 3 adjacency, the optical guys see all of this stuff in the middle, which is a lot of physical parameters associated with the physics of delivering a service and a wavelength over that level of distance. So in order to kind of deliver a solution that's workable, operationally, you need to satisfy both camps in the same solution. So that means telemetry, alarms, and the fundamental instrumentation of how the optics work within the router and what gets exposed northbound is critical for its success. And when you kind of look at the useful analogy, like we know, like most people have smartwatches and all these things that can sort of track health, but the intent there is to, at a high level, use that kind of sensory technology to track your baseline, and then based on once you have enough data and you have the baseline established, turn that data into insight. This is no different. So when we look at how we make optics work in a router, Ciena uses the exact same software SDK that exists on our optical platforms. We embed the same thing in the routing platform. So from a data perspective, there's absolutely no difference. From a management, provisioning, tool set perspective, if it's a Ciena optic in a transport platform or a router, looks, feels, provisioned, all the same. What that allows you to do is effectively get much more detail out of the router on a per parameter basis. More parameters, but it's also about granularity of those parameters. It's not just about the instantaneous value. It's about the tracking the average, tracking the minimum, tracking the maximum, and time stamping those so that over time you can develop that baseline. And once you develop that baseline, you can now use it to measure the performance of the network and how it evolves, right? And you can use that to build that network baseline, which means from a measurement perspective, you can watch trends over time. You can anticipate when you're running out of capacity. You can anticipate when you're going to run into an issue. You can also use that to make sure that you protect the SLAs that you set with your customers. There's a lot of ways that you can use this technology to make sure that you're delivering service at the way that you need to for your customers, but also make sure that you can track this moving forward. And the other thing you can do with it is make sure that you can use this kind of data for optimization perspectives. Here's a quick example. ESNR margin managed on a router port. You actually have a delta in terms of the bandwidth requirements that you have, and you have margin available. So you can actually extract more capacity out of that wavelength because you have the instrumentation and the data off of the router, and you've established the baseline such that you know that you can actually extract more physical capacity out of that link, which translates to more services that you can deploy on that wavelength. And so what does that mean from an IP perspective? Well, you can now grow that existing wavelength from 1.2 tera over the long haul or to 1.4 and actually squeeze more revenue generating services over that infrastructure. So you can now unlock sort of hidden optical capacity for IP service delivery. So just to wrap up, I think I covered 3 key things. First thing was around expanding use cases, pushing coherent routing to new parts of the network, the access for new deployment types for better cost per bit and more service coverage, optimize over long haul, as well as simplify operations by bringing that level of intelligence that we get on the optical side to the routing side so that the operations teams can adopt coherent routing solutions in a much more effective manner. Thank you.